Okay. Now, why are we here and what I want to talk about? There's two things I'm very much in love with. One is security and the other one is operating system internals. I teach both, and I'm actually I'd almost say like honored that they gave me the chance to host this session, because this is not an easy session to get. There are certain people at Microsoft who usually do internal stuff, so it's really hard to get this session, and I've been trying for many years, so now I finally got it, and it's the best possible way for me to wrap up Ignite for this year. If you have no idea who I am, my name is Sami Laiho. I'm from Finland. I've been doing this for a few years, about 20 years as an admin, publicly speaking and teaching for about 15 years. And that's the official side of things. Now, I've been doing this for the whole week, and I'm continuing. I'm trying to please as much as possible of the audience, because there's so many Swedes and Finns, or not that much, but there's huge amounts of Norwegian people. So do we have any Norwegian people here? Wow! Awesome. Because during the week I've met quite many Norwegian people, and there's one thing I can't get up, I don't understand what's happening, is I'm showing them my computer, and all the time someone comes to me and says like, wow, man, dude, that's awesome, like we heard you travel 200 days a year, but like, wow, and like, I have no idea what they're talking about, until a Norwegian guy who was singing karaoke as well, not that well, but as well, he happened to tell me that apparently kone, which in Finnish means a computer, in Norwegian it means a wife. So I had my team viewer open all the time, and all my remotely managed wives are there. So all the time wondering, like, what the heck's happening? Everyone go, high five, awesome dude, that's good for you. So, now we learn Norwegian. Kone is a computer in Finnish, but it happens to be wife in Norwegian, okay? I got certs. I love this picture so much that I'm showing it on every single session, but this might not be maybe this is not your first session with me, so you've seen this many times already, but I used to always tell that I have huge amounts of certificates, and I listed them, and I was super proud of them, but then it became a bit too much to show, so now I only show this 2.6 pounds of certificates. That's a Finnish scale, so it's 1.2 kilos, but about 2.6 pounds, okay? Windows 10 is amazing. Don't you just love when someone tells you that Windows 10 is the last Windows ever? Think about it, there's a certain executive president or whatever from Microsoft, and he comes in front of the whole IT Pro community that has been totally been let down with Windows 8. Everyone knows Windows 8, you had a consumer preview, you had a developer preview, like somehow they forgot us. I mean IT pros. So now this guy comes in front of everyone to announce Windows 10, and he says, you IT pros out there, now we want to please you. Windows 10 is the last Windows ever, and now we have a transparent command prompt. Did you just say that's going to be the last Windows ever, and the coolest thing you can offer us is a transparent command prompt? Of course, he did a small mistake, because he was supposed to talk about the new console host, not command prompt, because for the past 10 years they've been trying to tell us that we have to go PowerShell. So that would be ridiculous to say that you get a better command prompt which supports Control-C, Control-V and all that cool stuff. That is the conhost.exe, which is used by PowerShell. And that's actually cool that they made it better. But that's a bit poor marketing, saying that now you get this cool new command prompt, as everyone should be going PowerShell. So we got all this stuff which people are talking. Think about this. I'm a Microsoft operating system MVP. So one of the biggest issues that Microsoft dealt with with Windows 10 Start menu in these newest releases, 1607, is that the Start menu was actually restricted to 512 objects. And now they fixed it. Now it supports 2048 objects. I don't know who, so honestly, has someone had the problem of running out of 512 objects in your Start menu? We got virtual desktops. Super cool. Virtual desktops are now supported by Windows. Well, why didn't Microsoft make a big noise about this? Why didn't they come out and say, now we support virtual desktops? Because you know that every single competing company would have said like Mac and Unix have done for the past 20 years. They didn't make a fuss about it because virtual desktops is actually supported since NT 3.1, even more NT 4 terminal server. But virtual desktops have always been in Windows. How many desktops? If you log on, let's say NT 4 or Windows 10, I don't mind, anything between those. If you log on, how many virtual desktops does one single user have? Did someone guess 4? That's a guess. Does someone know? 1? No. We're getting closer. Something between 2 and 4. Okay? Good guess. 3, yes. Sorry, I gave out all my swag on the last session, so I'm totally out. Otherwise, I could have given you a prize. 3 desktops. It's kind of weird, but there are 3 desktops for every user. What are those 3 ones? One is the one you're interactively using. Other one is the one that you get if you press Ctrl-Alt-Delete. That's your second desktop. And the third one is Screensaver. Screensaver uses its own desktop. So 3 are always reserved, even since the beginning of NT. So that's not a new thing. Next thing I hear when I hear some marketing people talk about Windows 10 is that you know how cool it is that you can now actually run applications in Windows. Seems a bit weird for me because I kind of had the assumption because of the name of the product that it would somehow be able to run applications in Windows. It's called Windows anyway. They're of course talking about the universal apps. Now this is the stuff that you hear on the, not saying that on the other sessions, but this is the marketing stuff. Windows 10 has these superficial things, but no one takes the 75 minutes to think about how much the operating system has fundamentally changed. What's the real cool stuff below the surface, not these, okay? So that's what we're going to be talking about. First, we'll take a short trip into operating system history, which I love doing. I do this on every class. There have been big changes in the operating system. We've got maybe the biggest changes since the beginning of NT. First of all, with Windows XP, Microsoft moved from 2 different departments, you could say. They had enterprise products and home products, and with XP they combined everything to be one. XP was the first one that was offered to both home users and enterprises. Before that, you still had the different sides of Windows 2000, or the best Windows ever, Windows Millennium Edition. Just love it. Yay. So that was one big change, especially for the company, of course, because they now only supported one platform and no more the home editions of what they had before. Then they went to 64 bits. That's a big change. It was actually done with XP. Windows XP had XP 64 edition, which I don't know if I ever have known anyone who would have used it, because that was the time, oh my God, Lasse Ihalainen. We just had that Finn just had his moment now. You do understand that you're not supposed to be proud of that. But now it's on recording, so you're just fine. So XP had Windows 64-bit edition, but it only worked on Itanium. So That was the problem. Itanium couldn't run 32-bit code, but all code needed to be translated from 64 bits to 32 bits, which made it dead slow. So technically it could run things, but it had to emulate everything. And I don't know if you've ever used an Itanium, but I think it's super for heating your house. It's awesome. It's crazy good. I've been trying to think about the best way of heating a house. I think it would be an Itanium and a heat pump. It's like circle the hot air of Itanium. Microsoft internally has a super cool nickname for Itanium. You know what they call Itanium? It's the Itanic. Sounds so cool, Itanic. That 64-bit change actually started to really work out only with the XP X64 edition after AMD introduced their 64-bit platform, which was then copied by Intel. Now we're talking about X64. That's a really, really big change, of course. Imaging, Windows Vista, the one who we do not mention. Might have been the most horrible operating system ever, but they did some really cool stuff. I tell my students whenever I'm teaching operating systems, I tell them that just take a note of how many times during the next 4 days I will say that this was originally introduced in Vista. This was in Vista for the first time. In Vista they made this. There's so many things that were made with Vista that people never get to appreciate that stuff because you could barely boot the operating system because it was so buggy. But it did a lot of good stuff. So imaging is one of them. Changing from a normal file-based installation to an image-based installation with Windows Vista. Great, really big thing. The other introductions are like UAC, security stuff. So I'd say security and deployment both had awesome things happening with Vista. Then we had Hyper-V, introduction of Hyper-V with Server 2008, a bit after its launch. That's of course a huge thing, changing to a hypervisor. Now VMware might still in many ways be the leader, but at least that's the time when Windows got its own hypervisor, and we need it for many things nowadays. MinWin, something that people don't talk about that much. I don't know how many of you remember MinWin. It was a project after Vista wherein Microsoft said that they could actually run a web server with 32 megs of memory. And at that time Vista was already requiring like a gig and up, so it was weird, remarkable. I have this problem quite often if people talk about server versions. You know that Microsoft is not very good with naming conventions, and this one is horrible because if you think about Server 2003 and Server 2003 R2, they were the same operating system. You just had CD2 with additional features, but the CD1 had Server 2003 Service Pack 1, so it was the same thing. So now everyone on the field knew that if you have something working in Server 2003, it will work in Server 2003 R2, because they are the same. Well, what happened with Windows Server 2008? Server 2008 was then followed by Server 2008 R2, which for many end users or customers sounds like it's the same operating system. Although the difference between Server 2008 and Server 2008 R2 is bigger than the change between Server 2008 and NT 3.1. So it's a really, really bad naming convention. Server 2008, if you ask your customer, do you want to have 2008 or 2008 R2, they're like, well, it doesn't really matter, it's kind of a service pack or something like that, it's not a different thing. But if you would ask them this using the workstation names that are used with the same kernel, if you have a business critical computer here, which is your only computer, you're a small company, you can't afford a server, so we're going to make a server out of this workstation, and it's your most critical workstation. Would you like me to install Windows 7 or Windows Vista? And everyone knows the answer, like who the hell would want Vista on it? It's like, come on, of course Windows 7, but those are the kernels, what we're talking about. Windows Vista is the biggest Windows ever. Windows has gotten bigger up to Vista, and after Vista it has only gotten smaller. 7 is smaller than Vista, 8 is smaller than 7, 10 is smaller than 8. What was the biggest change? And why is it bigger than the difference between Vista and NT 3.1? Because we changed to a two-part kernel. The whole base of the operating system used to be one big pile called NTOS kernel, and now with Windows 7, MinWin was introduced into it, which made the kernel a two-part kernel. We have kernel base, which is the small, some call it Cutler's kernel as well. So it's a really small base kernel, and then we have a bigger kernel. So the whole structure of the operating system changed. That's why you actually, I remember when I had Vista, Vista had this indicator light. Your hard disk light would be blinking day and night all the time. It works like a heartbeat. You knew if your computer was up and running or not. And then you install Windows 7, and you look at your computer, and you basically had to like hit it. Are you alive? Make a noise. Blink a LED. See, it didn't do anything, but they are super different. Same goes 2008 R2, 2008 Vista's kernel, 2008 R2 Windows 7's kernel with the new structure. 48 bits of memory, huge change, happened in 8.1. Again, a horrible naming convention because Server 2012 and Server 2012 R2, is there a difference? Some people will tell me that that's not really the difference. It's just few minor things, this and this feature, although you can easily say that the difference between those operating systems is astronomical, because Server 2012 supports 44 bits of memory. Server 2012 R2 supports 48 bits of memory. The other one will give you 8 terabytes of virtual memory for your Excel if you want. The other one will give you 128 terabytes. So astronomical, okay? Some people look at those values like, does it really matter? Because 8 terabytes or 128 terabytes, come on. Like I'm quite sure I'm going to kill you if there's someone here who has 8 terabytes of physical RAM on their laptop. This might sound ridiculous. Well, like, what the hell does it matter? Security-wise, it's a huge difference because address space layout randomization, ASLR, will randomize your memory locations, and the playground that it has is either 8 terabytes or 128 terabytes. So security perspective, it's a huge difference. And you also, something that is good to keep in mind is that back in 1993, when NT was introduced with this 2 gig virtual memory, which now sounds ridiculous. But at that time, an average high-performing workstation had an average of 8 megs of memory. So 2 gigs was astronomical. So in IT, it's usually very wise to say that we will never run out. It's like, I think Bill Gates actually said that we will never need more than 640 kilobytes of memory on a computer. And also, I hear some people telling me IPv6 addresses will never run out. Yeah, sure. Amazon starts put IPv6 addresses on every box they send out, and come on, like we're going to run out in a few years, if you ask me. So in IT, we don't say we're not going to run out. Now, secure kernel is probably one of the biggest things that has happened in the history of Windows. Now we're not running a 2-part kernel, but we're actually running 2 kernels. So we'll talk about that a bit later on. Now let's get back to Windows 10. One big change that actually does change the whole thing about Windows is biometrics. I get this question quite often on Twitter, like, Sami, is it really true that it still works like this, that you really have the password, and you have to have that password, and then you protect that with biometrics? Like, when will Windows be smart enough that we can just store the biometric data and not protect an old password? If you are worried about that, think again. Because if you lose your password, what do? Change your password. What if you lose your finger? I've told when people start this conversation, I always reply on Twitter the same thing. With biometrics and fingerprints, you can only be palmed 10 times. So think again, do you really want us to have the biometric data there as your identification, and that gets stolen? Or would it still be better that we have the password, which we can then change without changing your fingers, okay? Now, this is super happy, and I'm super happy to do this now because I've been waiting for this for the whole week. Many of you have seen this, but I remember last Ignite, something was so funny because I did a session on, its session was called Zero Admin, Zero Problems. And I did a demo of showcasing people how I use my admin rights, okay? So most of you have already seen this, but I always get a rush of just doing this because what I do is I have a normal limited user and then I have an admin user. Like more there are of you, it makes me feel so happy to give the finger and not being thrown out of a conference. Now, what was the funny part was the fact that I did this demo at Ignite last year and I had 2 so great evals. Because on the evals they said, we will come back to Ignite next year, still believing it's going to be Chicago, so it says we're going to be back to Chicago for the next Ignite, just to see Mr. Laiho do that same demo with the facial recognition. Okay, that's interesting. So now I need an admin face. The other eval was even better because it says, we'll be back to Ignite because we want to see Mr. Laiho standing on his hands and showing his ass to the camera. My acrobatics are not that good, so I'm not going to do that demo, don't be afraid. That would have been cool. So now I had to start up figuring out how this thing works. So what I came up was, I had different ways of doing this. So first what I did was that I started, I have to get my computer, turn it a bit. So what I did first was this. This was my admin. So normal limited face, I know, it's limited. My limited face, and then whenever I would need admin rights, I would salute to my computer. But now the problem was actually airport lounges. Think about me sitting with my computer with all the other nerds there with their computers and going like this. So then I invented the Homer face. Now I do this. And it works in the airport lounge because Mac people will be around me, and when I need admin rights I do this, and they will go like, what are you doing? Windows, you know. So now I have fingerprint detectors, or if I'm using the Hello device, then I'll just do sorry, that's the wrong one. Then I'll just do CMD and elevate. And when I want to elevate, I will actually just have to go a bit closer to get this to work. Now, don't take the user. I don't want to use the fingerprint. Now, okay. It's a bit fast now, so it should say hello Homer because I now changed my admin name to Homer because I thought it was appropriate. That's how I live, biometrics. But honestly, take my word for it, get a fingerprint reader. They're selling them on the store here. If you don't have a fingerprint reader, take it. It's so much easier. I love it. It's just whenever I need to elevate, give it the finger and good to go. And it's very nice in the help desk as well. Someone comes to me like, Sami, can you help us out? Can you help us install a software? Yeah, you just need this. Then they go away. Problem solved. This is now actually starting to work quite well because I was super happy that I can show you one thing. These are my friends from Sweden. They sent me a picture after the training. Here's your admin faces. At least in Sweden, my admin stuff is working out quite well. People are learning. It was awesome. I promised the guys I'm going to show it here. Get there prime time. Sometimes these Windows Hello things don't work out that well because it's actually this is what I look like in the morning. Some reason Skype for Business steals 2 of those cameras and leaves only the depth camera, the 3D cam on. Really, I had a rough morning anyway, but seeing that on the, like doing the demo here and seeing that, like, oh my God, do I look that bad? So they have some issues, but it's getting better and better all the time. And it is actually, I would say that is one of the game changers of Windows 10. So that will honestly be a big, big thing. I will not use the admin face now because I have a fingerprint reader and I just trust me, it works a lot better. So that's my honest recommendation would be to get one. Now let's talk about memory internals first. That's what I already spoke about, so I'm not going to talk about that much. But if you would compare Windows 10 to Windows 7, because although Microsoft wants me to compare it to 8.1, I still believe that most people are actually transforming from Windows 7 to Windows 10. So then this will be your situation as well. So that's the old 2 gigs. In the middle you have Windows 8 or Server 2012 with the 8 terabyte memory, virtual memory, and on the right hand side that's Windows 8.1 or Server 2012 R2 with the 128 terabyte virtual memory. So I mean, the whole memory is 256 terabytes, but it's split among kernel mode and user mode. The user mode processes. That's kind of cool thinking about Notepad running with 128 terabytes of memory. Should be enough for Notepad. Excel, I've never had the idea of why the hell would anyone need more than 2 gigs of memory to load an Excel sheet. But I think Excel is some sort of like a separate universe or something, because when I see our managers, they can build like operating systems inside of Excel. So I guess someone will be happy about these big numbers for that use as well. Now that I remember, I had a student who actually told me an example where an IT pro would need 64-bit Excel. And I was like, honestly, you have an example where you would need a 64-bit Excel? Yes. What? When we go to IPv6 and we list all the static IP addresses in Excel, it's going to be 8 billion addresses. So it won't fit in 2 gigs. I didn't dare to say that I think your problem is that you're doing it in Excel. but yeah, why not? There's a lot of addresses, so why not? That's not a really, really big thing. This one is the big thing, okay? This is super cool. What we're going to talk about next is memory compression, which is on by default in Windows 10. You can't do anything about it. So let's talk about this. Normally, when you start running out of memory, your processes need to repurpose memory for something else. Now this, what's happening here on the slides, it's a bit bad contrast, I have to say. You have your working set there. Working set is the physical RAM used by a process. Part of the virtual memory of a process that exists in physical RAM is known as a working set. That working set is trimmed because someone else needs it. First, those memory pages that we're talking about, those memory pages will move to a modified list. Modified list has memory pages that have not been packed up by a packing store. So they're not stored in the page file, they're not stored in a memory mapped file on disk. So those are still the ones that need to be saved somewhere before they can be repurposed. Now we can put them in the page file. We can put them on the standby list, which is our cache. Standby list has memory pages that will probably be used again in a while, so they first stay in cache. And then maybe at some point we can repurpose those page files, repurpose those pages. Now, what happens in Windows 10 is something totally different. I'm out of reach. I've always been trying to figure out how to teach this thing, but this is my latest invention on how to teach memory. management, okay? So that's a table with pages on it. You could think of having like physical pieces of paper on your table. If you want to put something in that memory, you will not be able to fit a page in it. The only way is to take that page out, put it in page file, and only after that can you actually get a new page in memory. There are consequences to this which we never thought we would have, which is we never thought that this thing happening here would actually cause hard disks to fail. That's happening all the time now because of SSDs. So SSDs wear out. It's the problem with SSDs, they wear out. So we basically have to do whatever we can to prevent things from going into the page file, because if you put something in it, your SSD gradually dies. So people think about it, when people see this, they mainly usually think about, okay, Sami is talking about the reason Sami is talking about this is that we have these very small tablets that have really little memory. So we want to somehow optimize that. But that's not the big issue. The big issue is the fact that you want to keep things from writing to your SSD. Your SSD wears out. So what does Microsoft do now with Windows 10? There's another option. Take the pieces of the paper, compress them. You can fit a lot more papers on the table, okay? And that's what Windows 10 does. Compresses memory, which looks like this. Instead of a page moving from the modified list to the page file, it's first moved to a compressed store inside of your RAM. If you're still going to run out of memory, then gradually it will, at the end of the day, go to the page file, but it'll be compressed, which means that if you put things compressed onto your SSD, there's less writing to the disk. If you read something from there, there's less reading from the disk, because things only go to page file in a compressed format. Now, this compression, of course, has a price. Everyone knows that, of course, we could compress everything, but then compression means that we have to uncompress as well, which means CPU cycles, okay? So there's a price for this. So now, let's see about the price. This thing has been gradually getting into Windows, slowly, more and more. Every Windows version has had more of memory compression. Now in Windows 10 it's on by default for everything and you can't do anything about it. You can't switch it off. Should you switch it off? Absolutely not, even if you could, because it's super good to have. What people quite often don't think about is they draw me. This is what usually happens. They will, let's see if I can somehow do this. Do we have Zoom it on it? Of course not, because it's... I would wanted to draw something. This is what I get all the time, and you might too. So, if you get on, this one should have Zoom it, or if not, we will start it. Here we go. What people will tell me all the time is that when you have this scale here, and this is your RAM, if this is number 1, and this is your RAM, and this is your hard disk, this hard disk is actually 100,000 times slower than your RAM. But what's the greatest thing? Well, the lucky thing is that SSD goes here. And when you look at it like this, on this scale, it makes people think that SSDs are as fast as memory. Although if you want to draw a number there, that number should be 50. Normal SSDs are 50 times slower than RAM. So if you want to have a number here, that would be 50. I don't know about you, but if someone would tell me my neighbor's computer is twice as fast as my computer, I would be horrified. But it's not twice, it's 50 times. I think it sounds horrible. Also because people don't get this, they come up with weird things. I'm quite sure many of you have heard this. How to optimize Windows. silliest thing what happens with me and my colleagues is Microsoft has the most smart engineers in the world who have built this operating system, and they know a thing or two about how operating systems work. Yet, still, I find IT pros, friends of mine, who will rather read a web page with optimization instructions for Windows written by like an 11-year-old script kid. It's quite funny. So, because there's so many of these instructions around, you know, there's so much BS in those. First of all, they will tell you, disable superfetch if you have an SSD. It's the stupidest thing ever. You definitely don't do it. Why? Because it's 50 times slower. Of course you want to have superfetch putting things in RAM because it'll be 50 times faster. And they also say things like turn off defracking if you have SSD. That's super smart. SSDs don't fragment, that's true, but the defrag operation for SSD does a trim. So it's very important for your SSD. Do not disable that defrag if you got an SSD. Because this happens so much that these instructions are really poor, Microsoft was asked, one of their chief engineers was asked, could you please write an article about optimizing Windows so that we would finally get an official statement on how to optimize Windows. Ars Technica asked for this. And on Ars Technica you can find that document. And I can tell you how the document goes because I know it by heart. Because it says, install Windows, keep using it, change. So Ars Technica wasn't very happy about that one, of course, but it's kind of still really, think about it, it's quite funny that people still tweak their performance based on these instructions, which are not written by the guys who know how the OS works. It's quite horrifying, if you ask me. All right, so let's switch back. Here we go. Memory compression, how? Well, it's actually in your system process, which nowadays says system and compressed memory, so that people wouldn't be that scared. But if your system process, which is the process that's used by your kernel mode threads, that system process, if the memory footprint increases huge amounts in Windows 10, that's just fine. Don't be worried about it. It's not a memory leak. That's memory compression, because that memory that gets compressed is put into the user mode memory of that system process, okay? So it might be huge in some cases. Is this really good to have? So what's the price? The price is so small that you don't have to worry about it. These are just calculations based on a 3-year-old laptop can do 300 megs per second per core. One page is usually a megabyte or 8 kilos or stuff like that, so it's not much. Current laptops with 8 cores can do 7 gigs per second. That lowest end Windows phone is actually based on Lumia 530. That can do about 250 to 300 megs per second. So definitely have it on, it's not a problem. It's always wiser to have it than not have it, okay? It also makes your memory more organized. There's no fragmentation anymore. So that is also one good reason to have it on. So that's memory compression. That's one of the biggest changes in the whole operating system. And remember, it's there to secure your SSDs, okay? Just out of interest, how many of you attended my secure kernel session for 45 minutes? Okay. Sorry guys, this will overlap with that one, because I had a session about that one earlier, for the second day. Traditionally, we've had a structure like this. You have a kernel mode and you have a user mode. That kernel mode is a non-restricted area of memory where everyone has all the privileges, or you could easily also say that no one has any privileges, because there is no concept of privileges. Both would be kind of correct. There is just no rules. everything is shared. If something goes wrong in the kernel mode, it triggers usually a function called KEBugCheck X, which will cause a blue screen. If something bad happens in user mode processes, it should just say, we are sorry for the inconvenience, would you like to send an error report? So only crash that one user mode process. Now the problem is that if you get to the kernel mode, you own everything in user mode. So what's pass the hash? How does pass the hash work? Pass the hash works by lsas.exe, which is in the user mode. And now we just have to get that memory of lsas, because it houses the hashes that we can then pass on to other computers. So the problem of pass the hash comes from the fact that we can read that memory of lsas.exe. You can read it by installing a device driver, like procdump or something like that, or you can use a privilege called debug. Debug privilege is the way Mimikatz usually does it. It can use a driver as well, but usually uses the debug privilege. What we want to change is a world with two kernels, a normal kernel and a secure kernel. We've had these levels up and down, which are called rings, rings -2, -1, 0, and 3, user mode, kernel mode, hypervisor, UEFI, and now we have a lateral system on top of it. So we have two kernels, secure kernel and a normal kernel. How is this working? What we're trying to do is we will put the LSA ISO, which is the new isolated part of LSAS, and we will put that LSA ISO on the isolated user mode, which means that then we can't anymore read things from your kernel. Things running in the kernel like device drivers cannot access your hashes, and we effectively kill the whole problem of pass the hash. It only works on domain accounts. I'm sure you've heard a security session this week, many of you, that says that yes, but it only works on domain accounts, not local accounts. There is still the problem of pass the hash because local accounts are not protected. They're not in that LSA ISO, it's just domain accounts. Is Microsoft stupid, or why didn't they fix local accounts? Why did they only fix domain accounts? Because in 1993, when NT was published, there's a security guide, which is actually like this thick. It's really small at that time. But that small part in the user manual of NT 3.1 says that you can never have the same password for your admin accounts on two computers. That's why they don't fix it, because it's not an issue if you read the manual. Local pass the hash is not a problem, because since 23 years ago you were supposed to make sure no two computers have the same admin password. Then you can't have pass the hash problems. That's why they don't fix it, because they believe that you have already fixed it ages ago. Okay? We can see how this works. It's actually run by the CPU in a way. The CPU makes this possible. CPU secure stuff. I'm not going to go through all of this, but I want them to be on the deck, because some of you will watch this on a video and you want to see the slides, so I want them to be there. But I've already spoken about this on a separate session. I'm going to talk a little bit about a different thing which will change Windows 10 in a very, very big way, which is the new thing with Edge. Because now Edge will be able to run in a sandbox. And is that cool? That is just freaking amazing. That's the coolest thing. This is the first time I've ever actually thought about liking Edge. Until now I've only seen it as a pain in the butt because nothing works with it and I don't like it, but this actually makes me like it, because no third-party vendor can do that currently. If they build a sandbox, I've got so many customers using different sandboxing systems. They can't do it at this level. What Microsoft can do is below the operating system. You're running sandbox things on top of your operating systems currently. With this change, You have a separate operating system to run that thing on, and no one else can build it that secure. And that is awesome. And we're gonna like Edge maybe later, at some point, gradually. So that's why I'm just skipping a few of these, because these are kind of like old stuff. There's the process of how it actually works. How does secure kernel work? There is a thing called first level address translation. It's a normal memory management procedure done by Windows, which means that when a process starts, your process sees a virtual address, and then your memory manager will translate this to a physical address. That's virtual memory done for your processes. So your developers don't have to every time start an application by going through the RAM, figuring out if there would be an empty place somewhere in the memory to use, but it sees the memory as a virtual layout. It's an abstraction layer between the operating system and the physical RAM. If this is first level address translation, then when we do the same thing, but we do it for VMs, we got second level address translation, SLAT. Second level address translation is kind of the same process, but done a bit lower because it's done with VMs. We have to do the same thing because your VMs need to see things that they believe is real memory, which is the guest physical address, and then your hypervisor will have to map it to a real system physical address. But the greatest thing about this is that there's an access mask. I get excited about weird stuff, I know. But that's the most exciting part. Because we have an access mask, that means that below the operating system we can turn main switches on or off. That's a bit in the memory, but for you, it's off. Or I can say that that memory is there, but you can only read it, you can't write to it. So what actually makes secure kernel work, compared to what many people even in this conference have been saying, which is there is this tiny virtual machine inside of Windows. There's not a tiny virtual machine in Windows. That memory would, otherwise it would consume memory, that virtual machine, but you have the whole memory layout, you have two kernels, it's not a virtual machine. So what we do is we have two slots, so that we can have different rules. We can say that credential card, let's take an example, LSA ISO. We can say that that memory part is not readable from the normal kernel, which will then keep that LSA ISO secure. There's no way of accessing it. If you want to see proof of that, let's do this demo, but let's do it a bit different because I've done this on another session, so I don't want to do the same demo, so let's do another one. Let's go to the tool everyone loves, WinDBG. Start the debugging session on this box. All right. System does not support local kernel debugging. I actually thought I booted this in debugging mode, and that's my bad. What we'll do then is we'll have to cheat a bit. Let's use Mark's LiveKD. Actually, I'm not going to do that. Let's do this. Yes, that's what I thought. Don't have symbol files. All right. Back to a backup demo. Proc dump LSAS. .3 seconds and you've stolen all the hashes. That's why pass the hash works. We can read the hashes from the memory of that process. Now, with secure kernel on, things change. Let's do the same thing, but we'll do it for LSA ISO, which is the isolated part. Invalid access to memory location. It's a physical error of not being able to access memory. You can see the other people demoing how Mimikatz works, blah, 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 and doesn't work here, but I think this is a better and easier way of demonstrating the fundamental difference. You cannot read that memory. It's a physical error saying that you can't access the memory. I was going to show you those memory pages showing question marks only on the debugger, but I don't want to boot this machine, so that'll take too long. So that's why we got the backup demo. So what is VSM? What is secure kernel? It has so many names. One is called SMART. One name of that small new kernel we have is called SMART. So it's got really, really many names. People call it with different names. What is it really? It's more of a thing which is possible because of virtualization technologies. It's not a virtual machine. It currently houses 4 trustlets. So there are 4 things running on that isolated user mode, one of them being credential guard, one of them being biometrics information, one of them being virtual TPMs for Server 2016, and then device guard. Why is device guard so cool compared to AppLocker? Actually, device guard is horrible currently because it's totally unmanageable, but one day it will be really cool. Why? Because AppLocker runs on the user mode and the normal kernel, and any admin can just go and erase those rules. There is no security on AppLocker if you have compromised the kernel. What does device guard do? Device guard actually below the memory will tell that that application there is in a place in the memory where nothing can be executed from. It's a totally different thing than having a software thingy listing, whitelisting or blacklisting. That is a physical way of switching things off or on, okay? Then we have a new one coming next to it. Some people asked me this week quite many times, is Edge a new trustlet? No. Edge, the new Edge functionality is not a new trustlet. It's not going to be added to the list here because it actually gets its own kernel on the side. So it's not a thing running on secure kernel. So we already saw how that works. Now, something super exciting. Finally, we have the memory dumps that we've been waiting for our whole lives. Somehow I get the impression that you haven't, but I have at least. What we had before, let's get things straight. First of all, we had a possibility of dumping memory. Do you remember those tweak guides I was talking about? Quite many of them will also say that take the page file off the C drive and put it on another drive so it's better performing. That's silly. Because how memory dumps work is when your computer crashes to a blue screen, it dumps that contents of the memory into the page file. And it can only do it on the same disk unless you use a registry edit called a dedicated dump file. But by default, it has to be on your C drive, and it has to be big enough to get the memory dump in it. Don't tweak your page file settings. 99% of people don't have to tweak them. Some do, but 99% don't. That's the same thing they always told me. Put the page file in static settings. So say it's 2 gigs and 2 gigs. Why? Because then it won't fragment. That's funny. Because what happens when a memory dump takes place is that that memory gets dumped into the page file. That page file gets copied to memory.tmp in your Windows folder, and a new page file is created all over the place. So yes, that information was correct if someone told you that you can put it to static values to keep it performing, but it would perform better only until you crashed. After that, it would have been all over the place anyway. So that's a silly instruction as well. Now, we have different sizes of memory dumps. Small memory dumps are the ones that are always created and they are sent to Microsoft when you press the send error report button. They're very small. Then we have kernel memory dump, which is great because if your computer crashes with a driver bug, for example, then kernel dumps are usually perfect because that has the place where those crashes happen. Complete memory dump will take the user mode memory as well, and it will always be the size of your memory. So if you have 16 gigs of memory and you're only using 1 gig, that memory dump will be 16 gigs. That's the problem because you got these servers with 2 terabytes of memory now. Huge dumps, okay? And then automatic memory dump. I know I'm in a Microsoft conference and I shouldn't say that much bad things about Microsoft, but I'm keeping up what I started. There's a horrible knowledge base article on Microsoft.com. There's actually 2, only one is horrible because there are 2 documents that explain what's an automatic memory dump. The other one is correct and the other one is totally incorrect. Because the knowledge base article says that automatic memory dump would change the dump file from a small memory dump to a kernel memory dump, and if you crash again, then it would do a complete memory dump. And if you don't crash for the next 30 days, then it would go back down. It never does. It doesn't change. Automatic memory dump is always a kernel memory dump and nothing else. The only thing what makes it automatic is the difference is that Windows plays around with your page file size. It's a kernel memory dump, and that kernel memory dump needs page file. So in a small Windows computer, tablet for example, that page file is rather small. It stays like, let's say, 800 megs. So that it would most probably fit the kernel mode dump in. Now if you crash to a blue screen, what Windows does with this one is it increases the size of your page file to be the same as your memory. Because that's the only way it can guarantee 100% that it can fit your kernel memory dump. And then if you don't crash for 30 days, it'll shrink your page file down. So difference between kernel and automatic memory dump is just that the other one tweaks the page file size automatically. Now we have a new one, active, and that's awesome. That's the coolest thing. When my people come to my troubleshooting classes, I always tell them that after this class, when you go home, one thing has to change. And that what has to change is that when you see a blue screen, you have to go, yes! Because usually people don't like blue screens, but they're awesome. It's the best thing about Windows, because that's the only way we can honestly analyze stuff. It's great to have a blue screen. It's your best friend. Active memory dump is exactly like complete memory dump, but it only takes active pages. So finally what we've been looking for all the time. If you have a 16 gig RAM, but you only use 1 gig, that dump will be 1 gig instead of 16 gigs. So that's how it's always that's how we would always wanted it to work. Let's see this in action. This is one of the most fun demos I ever do. Sorry, I don't have prizes. But anyway, does someone know what an NMI is? Non-maskable interrupt. Quite many of you know it. Good. That's awesome. Because you can use an NMI to cause a blue screen. I go to weird extents in my blue screen love relationship because I actually buy these devices. Let's see if I can find it. Oops. That's the typo. Let's do a this one. I buy this from a shop. It's a PCI device which only reason for its existence is that it has a button that will blue screen your box. And usually when I start talking about this, people start taking it seriously when I mean that blue screens really are my most important tool. Because who the hell would otherwise install a device in their PC which has a button that you can never press? Self-destruct. My dad, when I was a kid, my dad had this server back at the factory that we own, and he had this server which still at that time had an NMI switch. And he told me, like, that white switch behind the server, you do not touch it. You know what a kid does when something like this. I had to try it and it crashed the whole server. Like, what? Dad, the server crashed. Why? Press the button. Now, what's cool about nowadays is we can bug check, we can blue screen boxes with PowerShell. That's just the greatest thing ever. Let me show you. We have a Windows 10 machine here, which has a complete memory dump that I've already taken. So memoryfull.dmp, which is in the Windows folder. Here you can see it. It's 2 gigs, because this virtual machine has 2 gigs of memory, okay? Now let's crash this with PowerShell. This is so fun to do. Just give it the admin finger. Debug VM is the commandlet. Give the name of the computer, which is ignite_101. Inject non-maskable interrupt force. See the computer back here. What I've done is I've changed it to do a dump, startup and recovery, but an active memory dump, not a normal complete one, but an active one, okay? So that's in place, and oh boy, can we have fun with our friends with this one. You have a new blue screen, because it's the 1607, so it has the QR code. That's what they added for the new Windows 10. And now it's going to do a dump. But now the dump will only be the size of the memory that's used, not the full size of the memory, okay? So that'll just take a while, so I'll let it do it and we can check it later on. There's huge amounts of bug check codes. This is my hobby. Whenever there's a new Windows release, I go through a file called bugcheck.h, which includes the new bug check codes. Honestly, I have no idea what these are. I don't have the slightest idea what they are. This is my next thing I'm going to figure out next week. When I get on a plane and I have nothing else to do, I'm going to figure out what these are. But I listed them and I see a few things that are very interesting, one of them being SMP server live dump, which would indicate that they are building a possibility of doing a SMP-based remote memory dump, which is cool, but I have no idea. Ari is almost smiling, so I'm not sure if he knows or not. I know he works for Microsoft, he might. He has that weird smile on his face. I'm trying to read his mind, if I'm right or not. But there are things of this HyperCard violation, for example, which is very important if we want to keep that Edge new browser thingy, whatever it was called, I don't remember the acronym, whatever it's called. If we want to keep that secure, we have to make sure no one compromises the hypervisor. So there's a thing called HyperCard. So it'll rather blue screen than sacrifice security. How's our dump doing? Now we should be able to continue. It's done. Here we go. Now it copied the page file into your Windows folder and renamed it to memory.tmp. And that memory.tmp is now around a gig. That's the same contents in both files. It might not look that big of a deal here, but think about those 2 terabyte machines. A really, really big thing for them. There are a few things on the operating system that I'm going to mention because they do fundamentally change how the OS works. Containers. Same OS, we're running kernel on Server 2016 and Windows 10, the same kernel. So both do get the container support. Now containers are a bit of, I always say it's like AppV for operating systems. It allows us to have these small instances of operating systems running on a box. We have two different kinds of boxes. Compared to the normal kernel mode, user mode stuff, we can have either a server container where you could say that the CSRSS, which is the user mode of Windows, is basically virtualized. So you get many copies of your user mode. On Hyper-V containers, you get many copies of your kernel. It's the difference between with these two different kinds of containers that we have. So that is a big thing. It changes things dramatically in the operating system. It also allows Hyper-V inside of Hyper-V. Do we have anyone here who's working for a training company, like Microsoft Certified Trainers, for example? Few. I'm a Microsoft Certified Trainer as well. I love this thing. Think about finally being able to teach Hyper-V for your students inside of a VM. Not many people might like to run Hyper-V inside of Hyper-V, but trainers do, because otherwise they've always had to have a dedicated hardware for the student to train Hyper-V. You can't teach Hyper-V unless you have a physical box. Now you can. Microsoft starts to also build these classroom installations so that they will send you a huge virtual machine which has huge amounts of virtual machines. So you can just send you one file and you put it on a box and you got your class running. So it is big for some people. Network has a lot of new stuff. This is something I wanted to have on the slides and recorded because so many people don't know about it. Microsoft doesn't make that much noise about these facts, but there are huge improvements in the TCP/IP stack. Really big things. I'm not going to have the time to go through everything, but I wanted you to have at least the RFC numbers, so if you want to go and dig in and check, but that is really big. So finally, since many, many years, we get something new for the TCP/IP as well. Less major changes. Drivers need to be signed. I'm on an MVP email list, which is currently very noisy because apparently there is a bug in the current release of Windows 10. Because what Microsoft said was that they need you to have Microsoft signed device drivers for Windows 10. But it was only supposed to be enforced in 1607 for bare metal installations. So if you do an update, it should not apply, but if you have a new installation of Windows 10 1607, then it will enforce this requirement. Sadly, TechNet forums and the forums I read are now full of these circumstances where a upgraded Windows 10 1607 starts kicking out unsigned drivers. It should not happen. It should only happen for bare metal installations. But for some reason, it's now happening currently. So just good for you to know. It's actually a really new bug. It's just for the past 2 days that I've been reading those reports. They're quite drastic because, for example, some USB controllers have unsigned drivers and suddenly you lose the whole USB, everything on top of it. I don't know if there's many of you who will enjoy this as much as I do, but I'm actually a big fan of the finally removed Windows Explorer limitation of 260 characters. It took a while. Why is it that? Why do I need it? Try to do a migration for a company migrating from Google disks, for example, and try to migrate them to OneDrive. That's awesome. Funniest project ever. Because OneDrive has the same thing in the limit of 260 characters. So that's really annoying. I can't do the migrations because Google supports 4K names, so I can't migrate stuff. I have to rename with PowerShell huge amounts of files to get on OneDrive. It's not yet on OneDrive. I'm not here to announce that it works today on OneDrive, but we are one big step closer to having it on OneDrive as well. So I think that is a big thing. I want to end this session and the whole Ignite from my side with something which is my own quote. I usually quote Benjamin Franklin, but now I decided to quote myself. Microsoft had a Ask Me Anything session in Redmond, AMA, very popular in US especially, AMA sessions. Microsoft had an AMA session in Redmond talking only about operating systems, not Exchange, no System Center, nothing. And it still takes 100 people in the room from Microsoft so that they can answer any question about the operating system. My students come to my classes quite often saying, I feel so bad because I didn't know that. I feel so bad because I don't know how Windows works. And even worse, they ask me something and I'm telling them I don't know, and they're like, if you don't know how this works in Windows, how would I know? Give yourself some slack. 100 people from Redmond are required to know everything about Windows. Many people go to work for Microsoft with the assumption that they will meet this guy who knows everything about Windows. So you can go and ask this guy anything and he will answer. And then they realize that it's a team of 100 professionals that's required. You don't need to know everything about Windows, okay? Give yourself some slack. Tell your users they don't have to know everything about Windows, because there is no one who knows everything about Windows. So, if you want to learn more, I got a plural site courses running. I've got my own training channel, winfu.com, called Dojo. I do courses in US, so join my courses. If you want to hire me, I'll come and do private classes very happily. Please do. And please fill the evals. Thanks, guys. Next year.